Hello, Mr. Aaron, Mr. Wan. How are you today?
Good.
Okay. So let's look at these sublists again. 0, 1, 5, 3, 4. Okay, and then like given a range like from 1 to 4. Okay, so this is a sublist. Let's say the numbers. And we want to find out the number of sublists with maximum between this range. So let's take an example. So the sublist 3 and 4, right? This sublist 3 and 4. What's the maximum is 4? It's between this range. So this is okay. And then 1, 3, 4. Yeah, these are all okay. These are all sublists, which the maximum is between this range, right? How about 0, 1? Yeah, it's okay. So how many of them?
A lot.
Yeah. No, not a lot. Just 5, right?
That is a lot.
So if the sublist is the 5 elements in the sub, how many sublists together? How many sublists for if this size is
15.
n? Yeah, 15. How do we get it? If
Because we do 1 plus 2 plus 3 plus 4 plus 5.
yeah, 1 plus blah blah. But
Because you can have a sublist which has only one element like this.
yeah, one element.
And there also can be a sublist which has two or more.
Okay, so with the
So it'll be C1n plus C2n. I mean.
okay.
And then that'll equals n times I forgot.
Okay. Look, you're basically right. Yeah. So like, if there are n elements, we want to pick one out of n. That means that the sublist with only one single element, like 0, 5, 3, 4, or 1. If we pick 2, it means that we pick 2 index, the left and the right, right? So it will be the sublist which with more than one element. So this is m plus n times n minus 1 divided by 2. So if I put the 2n over 2, this is the same thing. So we will get n plus 1 divided by 2. Okay, so look, this is the formula of the sum for the first few integers, right? So 5 will be 1 plus 2 plus 3. Look, n equals 5. It will be 1 plus 2 plus 3 plus 4 plus 5 equals 15, right? So if you plug the 5 in, 5 times 5 plus 1 divided by 2, that gives us 15 as well, okay? So that's how we get it. So one example is that how can we solve this problem? I mean, obviously, if we can go through the brute forcing, yeah? If we brute force all the sublists, that's going to take us O(n) square time. But
So
to check,
O(n) cube.
yeah, because it needs another O(n) to check to get the maximum of the sublist and then to compare if it's between this range. Let's do this brute forcing first.
So slow.
Let's do this brute forcing first, okay? So in the meantime, we need to think what kind of algorithm can we use to make it faster?
Using your brain.
Yeah, using my brain. But how about your brain?
Computer brain.
Computer brain. But we need to test computer. Okay. Let's say.
So we will use computer brain.
Let's say today is day.
Yeah.
Okay. Let's say F. Okay. The nums, and then we have
Column.
lower and upper, lower and right. Okay.
Column.
So answer equals 0. Right? We want to count and put it in the length. Put it in the answer, and the length. Let's say we n equals length num, right? And then we need to brute force. Yeah. For I in range, alright?
Yeah.
Range n.
Column.
And then for j, basically we are brute forcing the left and right, and then the left and right could be the same. So we start with I, and then up to n, right? Yeah. Okay. And then the sublist. What's the sublist? S equals nums. Look, nums, and then start with I up to j plus 1, right? Inclusive, because up to j plus 1 means ij inclusive. This is the sublist, right? and then we want to get the maximum. So if okay, so L smaller equal than the maximum of the sublist S, smaller equal the maximum sublist, and answer equals plus equals 1, right? Easy, yeah? Brute forcing. Return what?
Answer.
What's the time complexity?
N square.
On square? What did I just say, Ryan? What's the time complexity?
Cubic.
Okay, look. On, another loop. On square. And then this one takes another on, so on cubic. Okay? On cubic.
That one.
Yeah. Space complexity, we're not really using any space, so that's O1 constant. To be strict, we are using constant term of space. Okay, we are using this answer, but it's constant. Okay, it's not. When I said we are not using space, that's not quite right. Okay, we're using constant term of space, so it's O1. Okay, make sense?
Yeah, but how's that strict?
Can you not throw that thing to the board, please?
How's that strict?
Strict. What do you mean strict?
You said
Okay, so I mean the accurate, more accurate.
I don't get how that's strict.
Accurate. What I mean is strictly speaking. Strictly speaking, what I said, oh, we are not using any space. That's not accurate. We are using constant term, constant space, right? Because when the number of elements in the numbers grow, it does not depend on the input. We are still using constant constant space. Okay. Okay. So that's the brute forcing. That's the brute forcing. Keep quiet, okay? So let's say we want to find out this max A is smaller than the right and smaller than the L, right? So how about if I calculate the part which is smaller than R first, right? So you include, look, if I put the numbers here, right? So I want to count how many in the range, right? Yeah? How many in the range, right? I want to count how many in the range here, this part, yeah? How about if I say, okay, first of all, I calculate this part. This is A.
And then you cut off.
And then I calculate this part. L minus 1 is here. I calculate this part.
And then you cut off.
This is B. So what's the answer here? So this bit, I want to calculate this bit C. Okay, C is between the numbers between this bit. C is between the L to R inclusive, yeah? So now I calculate it. Okay, so A is the part between the minus infinity to R inclusive, and then B is the part minus inclusive to L minus 1. Okay, so what's the answer? C. Come on, from the graph. I want to calculate this bit, and now I know this bit, and I know this bit. So what's this bit?
That's C.
Yeah, so C equals what?
C equals B.
B is this bit. A
minus B.
Yeah, A minus B, exactly. C equals A minus B. Okay, so the same here. We want to calculate we want to count number of sublists, right? Number of sublists that the maximum is between this range. So let's say we count the number of sublists which is smaller than R, and the number of sublists which is smaller than the maximum value of sublists smaller than L minus 1, right? And then A minus B. Then we can do this twice, right? We calculate. So basically we calculate FR, and then we calculate FL minus 1, and then we minus it. That will be the answer. Make sense? Yeah? So now, how do we calculate this? This is the thing we need to know, okay? So let's say, look, I have a sublist. If it satisfies, okay, 100 here. This is the maximum I want to, the upper bound, okay, maximum. Okay, 1. How many sublists?
1.
Another number like A. How many sublists?
3.
10. How many sublists?
6.
Okay, so you keep adding that. How about now I add 1,000? How many sublists? Do you add it? You don't add it, right? No, because you can't add it, because this is more than 100. So we reset it to 0, okay? And now, how many sublists?
1.
Exactly. How many sublists?
Now me 3.
Yeah. Okay, you get it? Yeah, I know we can count it. Yeah, well done. Okay, so that's the way, right? We have a current counter. We accumulate as long as the current number is smaller than the upper bound. Right? Define, let's say, f. Okay, this is the num. That's the upper bound. Let's say the upper bound. Upper bound. So current equal answer equals 0, and we go through this number for I in numbers, right? If I smaller equal than upper bound, and then I need to current equal plus equal 1, right? Else I need to reset it to 0, right? And then answer plus equals current, right? Yeah? Yeah? Look, if it's smaller than upper bound, we accumulate the 1, right? And then we add the length, right? So it's 1 plus 2 plus 3 plus 4, right? That's how you get the sublet, number of sublets.
Plus 5 plus 6 plus
Yeah,
7
got it?
plus 8.
That's the happy pass. The sad pass is that if it's more than upper bound, then we set it to 0. Then answer plus 0, right? Make sense? And then return what?
Return.
Answer. And then the final return is return f r minus f l minus 1, okay? What's the term complexity here?
When?
This is O n, right? Because we're going through the numbers. A for loop. Exactly. Yeah. The space a constant term. How many times we need to call this function?
2.
Yeah, call this one. So that's O n plus O n is O2n, but we drop the constant, so it's O n, okay?
Yay.
Make sense? Okay, good job today. Bye bye.
Bye bye.
Bye bye.